Discuss the curve y equal x to the fourth minus 4x to the third with respect to concavity, points of inflection, local max and minima, and use this information to sketch the curve. Okay, well, first of all then, let's go ahead and look at a first derivative. That's going to give us 4x to the third minus 12x squared. Because this is a polynomial function, it will never be undefined and it's differentiable everywhere, so the derivatives will never be undefined, but we can figure out where the derivative equals 0 to find our critical points. So I'm going to factor out a 4x squared, and that'll leave me x minus 3. So it looks like we've got critical points at x equals 0. I'm going to go ahead and just mark this. So we have x equals 0, the first derivative is 0, and at x equal 3, the first derivative is 0. If we tested points on these intervals, then if we tried a -1, this would be positive and this would be negative, so this would be negative. Between 0 and 3, let's try a 1. This is positive and negative, so negative. And between 3 and infinity, let's try 4. This is positive and positive, so positive. So I've got decreasing, decreasing, positive. So this is a saddle point, not a max or a min. This is decreasing and then increasing, so this one is a local minimum. Now let's go ahead and find the second derivative. Second derivative is going to be 12x squared minus 24x, and we're interested in where that equals 0 to find possible points of inflection. Let's factor a 12x out. So we have 12x, this leaves x minus 2 equaling 0. So the second derivative is going to equal 0 at 0 and at 2. If I tested then points in these intervals, if I try -1 in the second derivative, this is negative and this is negative, so this is going to be positive. If I try a number between 0 and 2, so I'll try 1, this is going to be positive and negative, so negative. And if I try 3, this is positive and positive, so positive. Now let's see what this tells us then. This tells us concave up until 0, there's an inflection point, and then it's concave down until 2, and there's another inflection point, and it goes to concave up. So let's see what this tells us about the graph. We have a decreasing graph between -infinity and 0 that is concave up. Then we see that we still are decreasing from 0 to 3 here, but from 0 to 2 we change to concave down, and then we change back to concave up, and after 3 we change to increasing. So we can put these points on our graph and sketch this curve. So let's get maybe an intercept point, because that's easy to find. When we put in 0, we get out 0. So we can kind of get a point on our graph sort of for guidelines for starters, and we'll kind of go from that point. So at 0, we actually know that 0 is an inflection point because we changed from concave up to concave down. It's also a saddle point because it was decreasing and then it continued to decrease. So let's do a function. I'm going to move to the right here, and I need to be, this needs to be an inflection point, so I need to be concave down and decreasing after that. So let's do concave down, decreasing. And we continue like that until we get to 2. And when we get to 2, then we need to still be decreasing, but we need to change to concave up till we get to 3, and then we need to be increasing. Now, looking over here to the left, this was an inflection point. It needs to be concave up on the other side and decreasing. So our graph looks roughly like that. Let's see an exact graph. And we didn't do too badly. We actually didn't plot this point down here, which was the minimum, and to get some more accuracy it would be good to do that, because we did locate that the I didn't write it right here, and I should have. We had an inflection point here, and we also had an inflection point right here, but this particular point, I mentioned it, but I didn't write it here. This was a minimum, and so any of your extrema, it's good to actually substitute them in the function and get a point. So I should have put that in up here, and this is 3 to the 4th minus 4 times 3 to the 3rd. And that ends up giving us negative 27. And we didn't put a scale on this, so we're actually okay, but it's good to label that point.